All right, for today's lesson, we're going to be learning something new. We're going to be looking at what's called constant proportionality. It flows kind of right into what we just finished up, which was unit rate. We're going to be looking at 4 different types of sections today. So the first section we're going to look at is our equation, and then we're going to move to our table, and then move into our graph, and then to our word problem. The second page of notes is going to kind of go into more detail of what is our K, how do we find it, and is a problem constant proportionality, how do we know about looking at it, what we're looking for. Okay, so this is kind of an overview of what constant proportionality is, and then the next page we'll kind of go into more detail. Friday, you are going to have a quiz over what we did today and what we do on Thursday. And so please pay attention. And if you have questions, please let me know as we continue on to this as tomorrow as well. Okay, so constant proportionality. We're going to be using this scenario where a banana costs 25 cents a pound. So we have 2 equations. So one is obviously going to be constant proportionality, one is not. So our equations have to be in the form of y equals kx. So we'll start with this. X will always be x. Okay, k is going to be a number, and y can also be a number. Sometimes y will be y, sometimes y will be a number. So be prepared to see y, and then y can be a number, but k will always be a number, just like x will always be x. Okay, so we've got 2 equations right here. Y equals 0.25x plus 3, y equals 0.25x. So let's start with this one on the right. So 0.25 is a constant of proportionality, okay, because it's in the form of y equals kx. So y was y, 0.25 was our k, and then x was x. So in this type of problem, since it's constant proportionality, we say this is proportional. Okay, proportional, the way I think about proportional, it means it's kind of consistent. So it's the same thing over and over and over again. It's not going to change. Whereas our y equals 0.25x plus 3, so y, it's not proportional. The 3 is a constant. So what happens is this 3 is changing different numbers. So we're timesing something by 25, and then we're adding 3. Whereas this other equation, we're timesing it by 25. And it doesn't matter what we times it by, we still are timesing it also by 25. So it cannot have anything on the end. That is why this one is wrong. So I'm going to put an X. So this one's wrong, and then this one's right. I'm going to put a check mark on the other one. So, which is not proportional. In 8th grade, you'll be looking at like non-proportional, proportional. So you're kind of already doing what you're going to be looking at in 8th grade. Okay, so kind of digging more deep into the equation part. So the K is what we call our constant of proportionality. Okay, and then Y and X are actually what we call ordered pairs. And we can also put in numbers. So we're going to say input and then output. So we can input a number in for X, and we can get out an answer for Y, or we can put a number in for Y and we can get out an X. Okay, so that is the equation part. So it's going to be Y equals KX, nothing on the end. So if you see anything on the end, that means it's not proportional and it's not going to work. Okay, so next is our table. So we're going to use the scenario above, which was 25 cents a pound. Okay, so 25 cents a pound. Okay, so if I have 0 pounds of bananas, it's going to cost me $0. If I have 1 pound of banana, we know it's going to be 25 cents. If I have 2 pounds of bananas, so that'd be 25 and 25, that's going to make it 0.50. If I had 3, it's 25, 25, and 25, which is 75. If I had 4 pounds, that's 25 plus 25 plus 25 plus 25. So 4 25s is $1. Okay, this last one is 12. So what we've been doing is we've been taking 25 cents and timesing it by 1. And then taking 2 and timesing that by 25 cents. And 3, timesing it by 25 cents. So if I have 12, we're going to times that by 25 cents. So let's multiply 25 cents times 12. So 2 times 5 is 10, carry our 1. 2 times 2 plus 1 is 5. Add a 0. 5 times 1 is 5. 2 times 1 is 2. Then we'll move our decimal over 2 places. And so we get $3. So the x is where we're going to write our equation. So what we did is we took 25 cents and times it by each one of these. So what we're doing is we're doing 0.25 times x. So the next part is write a proportion using any set of ordered pairs from the table. Okay, so what they're doing is they're trying to want us to focus on seeing how they're proportional. So when we're looking at a table, it wants to be in the form of right here. Let me draw an arrow to that. To find your k, it's going to be your y over x. So in this case, our pounds is our x, and then our y is our money amount. So what we're doing is we're taking 25 cents and dividing it by 1, which is 25 cents. Okay, but then if I take 0.50 over 2 and divide that, so 0.50 divided by 2, we get 25 cents. If I did 0.75 over 3 and divide that, we get 25 cents. So we can say that our constant is 25 cents. So on your next page, we're going to be looking more about how do we find, looking at a table, how do we know if it's constant proportionality? Well, we take our y over x, which we did, and then we divided it, and if we get the same number all the way through, we know that is constant or proportionality. And then our k is a number that we got the same, which is our 25 cents. So again, we'll look more in detail on this on the next page with our graphs, our tables. Okay, so now we're going to look at the back side. So that's going to be our word problem and our graphs. Okay, so for a graph, it must go through the origin. Okay, so what is the origin? Well, the origin is 0, 0. Okay, but once we find the origin, we've got to figure out what is our k. K is just like our table. It's going to be our y over x. Okay, so let's first see, is our graph, is it constant proportionality? So we're going to say yes, it is, because it goes to the corner. This is the corner of the graph. We're only going to look at one quadrant right now. And so if it goes to the corner, that means it is constant proportionality. So how do we find the k by looking at a graph? So we know it's going to be y over x. Okay, but if you notice there's no y, there's no x. So how do we know where it is? Okay, the bottom line is our x-axis. So pounds is going to be x, and then our price is going to be our y. That's our horizontal axis. It goes up and down. What we're going to do is we're going to see where does it cross. So we're going to take we're going to start each dot, and we're going to draw a line up and then drawing it over. Okay. So for this one, there's not a number here, so I'd rather use a number that's on there just because we can see it. So if we go up from 2 and then go over, we really don't know what number that is. We can guess and think maybe it's 50, but what if it's 52? We don't really know. So let's go to the next one, which is 4. We go straight up, so there's 4, and then we can go all the way over, and it connects to 100. Okay, so if we look at 6, we go up and go all the way over. And again, it goes in the middle of a line in between 160 and 140. So we're not going to use that one because we don't know exactly what that number is. We can guess, but what if we're wrong? We really don't know. So we're going to use 140. So the 100's on the y side. So that's going to go on top. And then the 4 is our x. So that's going to go on the bottom of our fraction. Oh, and this says cents, so 100 cents is $1. So we're going to put that decimal point between the 1 and the 0. So it's wanting us to find the constant proportionality, or same thing as our unit rate. What does it cost for 1 pound? So we're going to divide 4 into 100. So 4 will go into 10 2 times, which is 8. We're going to get 2, bring down our 0. 4 will go into 25 times. So we get an answer of 25 cents. So our K is 25 cents. Okay, so if you look back up here between 0 and 2, that is 1. But again, if we draw that line over, it's not at 20. So that's why we didn't even use that one as well, because we really don't know what the number is. So I'm going to stick to the numbers on the bottom that are there and draw those lines and see if it crosses somewhere. So the next question is, how much would 15 pounds cost? So we know it's going to be 25 cents for 1 pound. So we're going to take the 0.25 and times it by 15 to see what is it going to be if we had 15 pounds. So 5 times 5 is 25, carry our 2. 5 times 2 plus 2 is 12. We'll add our 0. 1 times 5 is 5. 2 times 1 is 2. Now we're going to add. Then we'll move our decimal over 2. And so we get 3.75. So if we buy 15 pounds of bananas, it's going to cost us $3.75. Okay, so again, on the next page, you're going to do kind of go into more detail about it, about graphs, how to find our K, and then what does it mean for it to be constant of proportionality. So again, it must go through 0, 0, which is our origin, and then to find your K, it's y over x. Okay, so our last one is we're looking at word problems. So the word problems are just like your equations. They must be in the form of y equals kx. So we're going to write the equation first and see if it works. And then we will solve it. Okay, so Mike Monks purchased some bananas for $2.25. If there were 25 cents a pound, how many pounds did Mike Monks purchase? Okay, so our $2.25 is our total. Okay, and it's 25 cents a pound. We don't know how many pounds, so we're going to have that next to x. I dropped the 0 because we don't really need that. Okay, so this is in the form of y equals kx. Y is our 2.25. K is our 25 cents, and then x is x. So it's like a one-step equation. So this is multiplication, so the opposite is division. We're going to divide by 25 cents on both sides. So 2.25 is on the inside, and then 25 cents is on the outside. Okay, we've got to move our decimal over in both numbers. So 1, 2, 1, 2. Bring that decimal straight up. So 25 can't go into 2. 25 can't go into 22, but it can go into 225. Okay, this is quarters, so let's think about this. So 4 quarters make $1. So if I have $2, that's going to be 8 quarters. And then if I have an extra quarter, that's going to make it 9. And so how many pounds did Mike Monks purchase? 9 pounds of bananas. Okay, so this next one is a little bit different, kind of like your homework that you did on Monday. It's kind of a multi-step process. So Mandy Monks purchased 3 pounds of bananas for 75 cents. How much will it cost if Mandy Monks purchased 11 pounds of bananas? So first is we've got to find the unit rate. What does it cost for 1 pound of bananas? So it's like we did Monday and Tuesday. It's finding that unit rate. So the money's going to go in. And again, I just drop that 0, 3 pounds on the outside. And then we're going to divide. So 3 will go into 7 4 times, or not 4 times, sorry, 2 times, which is 6. 7 minus 6 is 1. We'll bring down our 15. 3 will go into 15 5 times. So we know it's going to be 25 cents for 1 pound. But what if we had 11 pounds? Well, we could do 0.25 plus 0.25 plus 0.25 over and over again 11 times. Or a quick way is to multiply it by 11. And then that's going to tell us how much it costs for 11 pounds. So 1 times 5 is 5. 2 times 1 is 2. And then 1 times 5 is 5. 2 times 1 is 2. And then we can add 5 plus 0 is 5. 2 plus 5 is 7. And then bring down our 2. Move our decimal over 2 times. And so we get $2.75. Okay, so the next set of notes, again, it's going to go into more detail over each section. And then your homework will look kind of like the page that you're about to do, but it's still the same concept of all of this. Okay.